Hey, today we're talking about rational exponents. At the top there, you can see a rational exponent. It's going to be a fraction. And so the key is we can change a fraction exponent into a radical. So when we reviewed simplifying radicals, that's coming back into play. So if you need to go back and review, go back to previous notes or previous weeks of lessons, lesson videos, you can do that. But we are simplifying radicals again. We're going to be changing those fraction exponents into radicals. You can see my rule here that if I have a to the m over n, if I have any kind of fraction right here, I can change it into a radical where n becomes the index, that little bitty number inside the check mark of your radical is called your index. And then inside the radical will be a to the m. The numerator becomes the exponent inside the radical. And it says where n represents the index and a to the m is the radicand, the thing inside the radical. Big thing here, the denominator of my fraction exponent, the denominator becomes the index. You're going to hear me say that a bunch. All right, so let's get started. Let's look at number 1. We have x to the 2/3, and it says just write the expression in radical form. Take it from a fraction exponent and put it into a radical. So I am, of course, going to have my square root. I said the denominator is the index. I'm going to highlight that. Super important. The denominator is the index. So my denominator here was 3. Little baby 3 goes inside. This is a cube root, and it's going to be x squared. Done. All right, move on. Number 2, x to the 1/7. We're going to change it to a square root. The denominator 7 becomes my index is the 7th root of x to the 1st, or we really don't have to even do that. We can just say a 7th root of x. Number 3, x to the 1/2. So change it to a radical. The denominator is 2, so we have a square root of x to the 1st, or we can keep it even simpler than that. We can just say the square root of x. Remember, if there's not a number inside your index, inside your check mark part of your radical there, it's an understood 2, so you can leave that blank. Let's look at number 4. So watch out here. Who has the exponent? Who has the exponent? Just the y. We have x times y to the 3/4. So let me go back to my blue pen here. The only part that's going to have the radical is the y. So we're still going to have x. Nothing happened to x. Y is going to have the radical. The denominator was 4, a 4th root of y to the 3rd. All right, moving on to the second section, we are going to write the expression exponential form. So we're just going backwards. We're going to take the square roots and write them with fractional exponents. So number 1, as I mentioned before, if there's not a number shown on your radical right there, it's an understood squared. And so if you look right above, we're just going backwards here with an understood 1. We have x to the index is my denominator. This is x to the 1/2. Let's look at number 2. There's an understood 1 right there. So this is x to the index is my denominator, x to the 1/3. Number 3, the index is my denominator with x to the 4/5. Simple as this, just writing them in one version or the other. You have practice just like this on Delta Math. Number 4, x to the 3/4. I hope you're catching on, okay? Let's scroll down and look at the third section here. Just simplify. So let's see what we can do. First off, you have a fraction exponent right here on your x. X is the only one that has the exponent. 3 is not involved in that. So let's see. I actually have, let's change our fraction into a radical. 1 over 3 to the. Change x to the 1/2 to a radical. The denominator is my index, so we're just talking about a normal square root of x. All right, number 2, you've got 3x all raised to -1/4. There's a couple things we can do here. First of all, both of these things are raised to the exponent, hence the parentheses, but our exponent is also negative. So let's go back. We reviewed exponents at the very beginning of the year. You're not allowed to have a negative exponent. If you have a negative exponent, it moves down into the denominator. Right now, This is understood in the numerator with an understood 1 in the denominator. So all of that is going to have to move down into the denominator. So let me erase this so we can see our problem again. I'm going to move it down into the denominator. And when I move it down in the denominator, the exponent becomes positive. So that's the first thing. Now, today's lesson, you have a fraction exponent. So let's change the fraction exponent into a radical. 3x is all in the radical. The 4 is my denominator, so that will be my index as the 4th root of 3x. Done. Number 3, 1 over all of this, 2x squared plus 7 to the 1/2. Let's fix it. It's not a negative exponent, so let's just change our fraction to a radical. 1 over, all of that is in the radical. The denominator is 2. There's an understood 2 right there. I don't have to write it. Square root of 2x squared plus 7. Done. Number 4, look at that. You've got a negative exponent in the denominator. Now that exponent is only stuck to x. So first let's fix that issue. The negative exponent in the denominator, that needs to come up. So now I'm going to have 1 in my numerator with x to the positive 4/3 over 2. 2 stays down in the denominator, nothing happens. And now I have a rational exponent. Let's change it. The denominator's 3. That's going to be my index. A cube root of x to the 4th over 2 is my final answer. All right, next page, simplifying rational exponent. So I gave you the basic exponent rules at the top. Let's walk through those really quick. So first rule that's listed here is a to the m raised to the n. That's a power to power rule. If you have an exponent raised to another exponent, you take those exponents and you multiply them together. Second rule, if I have 2 things in parentheses raised to an exponent, both of those things get the exponent. We kind of used that earlier. The third one here is your product rule. If you have same bases with different exponents, you can take the same base and add those exponents together. Here's that negative exponent rule. If you have a negative exponent, it moves down into the denominator or vice versa. Let me add that. If you had like 1 over a to the negative n, it would move up into the numerator and be positive n. It works backwards as well. Over here, you've got the quotient rule. If I have same bases and they're dividing, you subtract their exponents. And then this last one here, if you have something dividing inside parentheses raised to an exponent, you can give the exponent to both of those, numerator and denominator. So let's check out number 1. Simplify each expression. So I've got 3 things in the parentheses. You've got the 27, you've got the x, and you've got the y, all raised to the 1/3. So I'm going to use that second rule that's listed. I'm going to give everybody the 1/3. So I'll have 27 to the 1/3. For x, it already had an exponent, x to the 12th. And now I'm going to raise it to the 1/3. That's the power to power rule. The first one listed here, that gets multiplied together. So I have x to the 12 times 1/3, or 12 divided by 3 is 4. The y already had an exponent, raised to an exponent, multiply 3 times 1/3 is 1. Okay, so things are already looking a little bit cleaner. Let's change that fraction exponent into a radical. Since 3 is my denominator, I'm going to have a cube root of 27, then an x to the 4th and a y. The x to the 4th and the y are not in the radical, okay? What is the cube root of 27? Do you remember some of our perfect squares and perfect cubes? The cube root of 27 is 3. It's completely normal cube root 3. And then we have x to the 4th and y. Final answer, all cleaned up. Number 2, let's do the same process. So you've got 3 things inside the parentheses, the 8, the x, and the y, all being raised to 5/3. Let's give everybody a 5/3. So I have 8 to the 5/3. I have x already had an exponent, power to power multiply. Let me do some scratch over here, some scratch work. if you had -9 times 5/3, you could multiply across the top and across the bottom and simplify, or I'm going to do some cross cancellation here and get -15. So it's just x to the -15, y to the, let's do some more scratch, -18 times 5/3. I'm going to do some cross canceling, simplify, get a -30. All right, let's take care of those negatives. Ooh, you got some negative exponents. Let's move those down into the denominator. So we have 8 to the 5/3 in the numerator. And now in the denominator, x to the +15, y to the +30. And I'm going to apply today's lesson, change my fraction exponent to a cube root of 8 to the 5th. Okay, so let's continue to simplify. I don't know if you know the cube root of 8 to the 5th. So let me talk about a couple ways you can handle this. So one, if you have a more basic calculator, like this is a TI-30X2S, you can calculate the cube root of 8 to the 5th on this calculator. You first have to type what kind of root you're going to have. You're going to have to type your index. So we have a cube root here, so I'm going to type 3. And then I'm going to do second, and then the caret, because above the caret you have an x square root. So second, the caret, okay? And then 8 to the 5th. So just like this, and enter, and it's 32. So the cube root of 8 to the 5th is 32. Let me also show you on the Inspire. So if you go to a new document, on the Inspire calculator, you will use Control and above the caret as well. It's going to make your boxes for you. So we have the third, or the cube root of 8 to the 5th. 8 to the 5th. Enter. 32. So there's a couple ways you can do it to calculate your square roots. So let's go back here. We said it was 32, so I have 32 over x to the 15th, y to the 30th. Final answer. Number 3, you have, again, 3 things, all raised to the 3 halves, so let's give everybody that exponent. You have 9 to the 3 halves. You have x to the -14. So let me do some scratch work. -14 times 3 halves. I'm going to do some cross cancellation, simplifying to give me a -21. And then y to the scratch work. Let's see, -16 times 3 over 2. This will simplify to 8 and give me -24. All right. So we've got 2 things with negative exponents that are going to move down into a denominator. 9 to the 3 halves over x to the now +21, y to the 24th. And using today's lesson, I'm going to change my rational exponent to a square root. It is a square root. I don't have to write the 2 of 9 to the 3rd over x to the 21st, y to the 24th. Not sure what the square root of 9 to the 3rd is, so let me grab my calculator. Control. I can just use the square root because it's a square root of, what are we working on? 9 to the 3rd. 9 to the 3rd. Enter. 27. So 27 over x to the 21st, y to the 24th. Final answer. So you don't want any negative exponents, and we don't want any rational exponents or fraction exponents now that we're in Algebra 2. Number 4, same story, 3 things. You're going to have 32 to the -2/5 x. Let's see what 10 times -2/5 is. 10 times negative 2/5. Simplify a negative 4. And then y to the scratch work times negative 2/5. Give me a 4. 8, a positive 8. So we have a negative times a negative made a positive. So that's no longer a negative exponent. It's not going to move down in the denominator. The only one, well, we have 2 actually that are negative, move down. In the numerator, we still have y to the 8th. The 32 moved down and became positive 2/5 exponent. And x is now positive 4. Let's see what 32, well, let's change it. It's a 5th root of 32 squared, x to the 4th. And let me find out what the 5th root of 32 squared is. 5th root of 32 squared. 5th root of 32 squared. There's a quick squared button right here. And enter 4. 4x to the 4th. Final answer. So guys, that's rational exponents. So we're talking fraction exponents. We can change them from fraction exponents to radicals. The denominator is your index of your radical. We had to review some of our negative exponent rules. You cannot have a negative exponent. It moves from numerator to denominator and becomes positive, or if it was a negative exponent in the denominator, it would move up and become positive. Over here, we reviewed some of our basic exponent rules because as we were simplifying, we had to use the power to power rule pretty frequently. Yeah, just make sure that you don't have negative exponents and don't leave fraction exponents, and you should be good to go. Let me know if you have any questions, and I'll be glad to help.